David, welcome. Thank you so much for coming and for joining our Hangout series. The goal we had was to bring experts to a platform where people can ask questions about their career, about general life challenges, about innovation, and most importantly about challenges in Africa and how best we can look at those challenges from global. So can we just get started by asking you the first question? So we had some people send questions via email.
Okay, sure.
Yes, so we have like a list of questions, a lot actually.
Okay.
Yeah. So I've pulled out those questions and I'll just be going through them one after the other. So the first person said...
but before you start, just really quickly, I just wanted to say thank you for organizing this. And, you know, it's a real pleasure to interact with you and your colleagues and others. Yeah, so very excited to be here. And I also know that it's I think it's 6 p.m. Over on your time, right? So this may be dinner time. This may be dinner time on a Friday evening, so it might not be the best time to do this. So I apologize for any difficulty scheduling, but it's a real pleasure to be here, and yeah, happy to answer any and all questions.
Thank you so much. Thank you so much. So moving on, the first question, tell us a bit about yourself.
Tell us what?
A bit about yourself, like
a bit about myself.
Like summarize, like yourself, like just tell us about it.
Sure. So, you know, again, my name is David Sun Kong. I direct the Community Bio Initiative at the Media Lab at MIT. I'm also the founder of an Art, Technology, and Community Center in Cambridge, here in Massachusetts, in the US, called EMW. That's actually named in part after my father's field of research, which was electromagnetic wave theory, so EMW for electromagnetic wave, but also a Chinese language bookstore called East Meets West Bookstore, which is also a storefront that we have here in Cambridge. So if you ever come to Boston, please come and visit. I know some colleagues and friends that came to the Global Bio Summit this past year, including George from Kumasi Hive and Valerian from Stick Lab, were able to come and visit us at MIT. And also, actually, Valerian and George in particular, they actually stayed at EMW, my community center. So those are two kind of places that are very near and dear to my heart. I'm a synthetic biologist, so a big part of my work is developing technologies to make the living world easier to engineer. So this could be hardware. One of the things I work on is an area or a technology called microfluidics, or lab on a chip technology. So miniaturizing biological and biochemical processes into very tiny devices. I also do a lot of work in community organizing. So again, one of the things I'm most excited about right now is sort of in a way, the advancement and development of synthetic biology and DIY or do-it-yourself biology, but maybe into something new, maybe something called community bio, which is really thinking about global networks, right? Which is part of why I'm excited to engage with you all in thinking about how we can work and collaboratively across borders, augmented through digital tools, to really think about life sciences in a new way. And part of that, you can think about that, I think, in terms of collective intelligence, which is another domain that I'm very active in. I also collaborate very closely with the Center for Collective Intelligence at MIT, and I'm a principal investigator there as well. And basically, the Center for Collective Intelligence, I work very closely with a senior faculty member there called Thomas Malone, who is, in some ways, he's described as the father of collective intelligence. So he has written a book recently, which I recommend you all read, called Superminds. And the idea is basically looking at how different types of human organizations, which could be community organizations, which could be hierarchies or markets or even democracies, how you can basically organize people to more effectively accomplish whatever their task or mission is, right? Obviously, I work in biotechnology and in the life sciences, and so one of the questions is, how can you structure global communities to actually produce new types of innovations in the life sciences, right? And so at the Media Lab in my initiative, the Community Bio Initiative, one of the big events that we've organized for the past 2 years is the Global Community Bio Summit, which brings together folks from all around the world that are working on grassroots biotechnology. So, bio and the life sciences that's happening in many cases outside of traditional academic or corporate institutions and being done in a really community-driven way. And it's one of my beliefs, and this connects very much with one of the themes of the Media Lab, this idea of quote-unquote accessible innovation, that when you can lower the cost of innovation and bring in very diverse communities that have diverse technical backgrounds, creative backgrounds, socioeconomic backgrounds, cultural backgrounds, that you can really produce some exciting new types of innovations that might not be as obvious when you have a very defined discipline with a bunch of people that think very similarly, right? So I'm a big believer in diversity, both from an innovation perspective, but also from a moral perspective, right? I think it's important that for technologies like in the life sciences that we have this very, very broad global and diverse engagement. So that's a bit about me and a bit about my research. And I also just, I also am an artist, so I really enjoy DJing and photography and.
Expecting you to say that.
What's that?
I was waiting for that part.
Yeah, I love the DJ. I love photography. I also love, freestyle rapping and beatboxing. So I'm a big hip hop guy. And actually, after going to Kumasi last year for the African Open Science Hardware Summit, I'm now super into Afrobeat. I always play Afrobeat in all of my DJ sets now. Yeah.
Okay. So Isa, are you there? I saw you raised your hand. Isa, do you have a question? Okay. So I'll just move on to the second question. Isa, if you have a question, you can just ask us that way. So Sean said, how does your day look like on an average?
How does my day look like? That's a great question. Usually very, very busy. I tend to have, when I kind of get up, I tend to be more of a night person. So when I get up and start my day, I usually during the day, it's just all meetings, lots and lots of meetings. So during the kind of standard 9 to 5, like working hours, I'm meeting a lot and then teaching. So, right now, for example, I teach 2 graduate courses at MIT. And so, during the daytime hours, a lot of it is meetings around projects, collaborations, meetings around teaching, and basically, the day is mostly spent running meetings, being a part of meetings. So what ends up happening for me is, after my kind of day of meetings is over, I'll go home, I'll get some dinner with my family, and then the evening is really when I get more creative time. So it's kind of after dinner where I'll have the opportunity to, I do a lot of email in the evening. I never have enough time. There's always just way too much email. But the evening time tends to be unstructured. So my day is very structured. Evening is unstructured, and so that gives me the kind of freedom to be more creative and think about different ideas and work on writing projects and actually just answering a lot of email. So yeah, that happens for me in the evening, and then so that's why my collaborators are always getting all kinds of crazy emails from me very late at night, and then I go to sleep, and then I start again.
Wow, very hectic.
Yeah.
Yeah. So someone said, so how do you? So I don't know. I think they Googled you. So he said you are a musician / DJ, photographer, a community organizer, a synthetic biologist. So how do you merge multiple interests together?
That's a great question.
He said, how do you keep up with being focused when you have other interests to worry about?
Yeah, it's a great question. So, a lot of the work that I do in the arts, for example, like DJing is something that I needed to nourish my soul, right? I think, my partner, she always says, David, if you haven't been DJing, like, it's like bad for your health. You know what I mean? It's like, I'm a type of person where, I never regret, DJing an event or, a night dancing, so it's like, you need these things, we're humans, right? We're social creatures, and we need to have these different types of outlets. And actually, it's interesting. I feel like artistic endeavors, they help my science, they help my technology, right, work. So I think, I'm a big believer in diversity. And I believe that, when you have different types of interests that can be very varied, right, it actually helps your thinking, right? The fact that, and this is kind of, you may find this interesting. As I mentioned, I do a lot of work now in collective intelligence, and DJing actually helps me think about collective intelligence, right? Because when you're DJing, what are you doing? You're actually managing a collective intelligence, right? You have one unified consciousness that happens on a dance floor with a big crowd that's moving, and your ability to reflect on that consciousness. And in the case of a DJ, you're literally directing that consciousness through the music you play, right? And so I think it's through things like the arts and these other diverse interests that we can actually learn very valuable metaphors. And metaphors, I think, are one of the best ways that we learn, right? When you're engaging in science and technology, how you frame a problem and how you think about it is through a conceptual metaphor. If you think about synthetic biology, for example, what is synthetic biology? Synthetic biology is actually an experiment in mapping metaphors and concepts from engineering onto biology, right? Synthetic biology was founded by civil engineers, by computer scientists, notably by non-biologists, right? These were people that came into the life sciences and said, hey, I'm very good at building computers or building bridges or buildings. Why can't I build a system, a biological system, the same way I can build a computer, right? So there was a very interesting analogy there that we are still actively researching and testing, right? Is it possible to work with a quote unquote biological part, right? Something that you could define and characterize that has a well-defined input and output from which you can build a very complex device or system, right? This is something we do all the time in engineering. Could we do that in biology, right? So the ability to kind of access these different metaphors, I think, is a very valuable part of innovation. So for me, I know that I feel like my life has really become much more authentic and I've been living a much truer version of my own life by really combining all of these interests together, right? One of the best examples of a project that I never in a million years would have explored without kind of embracing my artistic life is this project called Biotebeats. Biotebeats referring to the microbiota, the collections of hundreds of trillions of microorganisms that live in the body, that inhabit the human body. So again, there's a big field of research in the life science called the human microbiome research, so studying these organisms and how they influence human health and development. And what's amazing is there's all this wonderful science that's being done, but what we did was we made an art project in a way where you could sample different organisms from the body. Basically, we have these records that they look like kind of vinyl records, except they're laser cut and they have a kind of a type of media, essentially bacteria food on them. You can grow the organisms, and then we have these algorithms that, and then based on the organisms and how they're growing, we have these algorithms that extract that data and then translate that data into sound and music. And so basically you can listen to a musical composition that is derived from the bacteria of the body, okay? And so this is a project that for people that don't know a lot about science, when they hear about, the microbiome, they're like, okay, cool. But when you hear that you can make music from the microbiome, that's a whole nother thing, right? Humans, I don't care about your political background, your economic background, or your whatever. Every human has a relationship with music, right? And so the arts, it turns out, are a really valuable way to actually introduce people into science. And so I think it's, and again, another one of the concepts we explore at the Media Lab is this idea of quote unquote anti-disciplinary research, right? That there are disciplines, but actually the real exciting work is happening in the space in between the disciplines, right? And so for me, combining things like the arts and the sciences and technology and design and engineering, that's where kind of a lot of the magic happens and where a lot of really exciting innovation happens. So it's a long way of saying, I think the diversity of interests is important for nourishing your spirit and your soul so that you can be a happy, healthy individual. But it's also important, I think, for innovation. It's also important for really pushing the boundaries of what we imagine to be possible.
Nice. Thank you so much. So let me just go to the next question. What's it like to work at MIT?
That's a good question. I have been at MIT basically my entire life. I mentioned my father was a professor at MIT. My father, he was at a really amazing story though. He was a child of, I'm a child of immigrants. Both my parents, they came from China. And my father in particular, really, had to flee China because of the Cultural Revolution, and kind of grew up on the run, and ultimately, went to college in Taiwan, and he met my mother in graduate school in the U.S. And so, I was very fortunate. My father's brothers and sisters, they basically grew up peasants in China, and my father, because he was able to escape and get education, became the world's most famous electromagneticist, right? And I grew up in a very nice suburb in the Boston area called Lexington, and I've been around MIT my entire life. So the question is, what's it like to be at MIT? It's kind of all I know, actually, because I grew up on the campus, and then I did all my degrees there. So I did my undergraduate, my master's, my PhD, my postdoc. Then I worked at a place called Lincoln Laboratory at MIT, which is a very big laboratory. I worked there for 5 years as part of the Bioengineering Systems and Technologies group. And then I did 1 year in a startup, actually, a biotech startup. That's my 1 year that I did not at MIT. And then, for the past, almost 2 years now, I've been back at the Media Lab. So I've been at MIT my whole life, so I don't have a lot to contrast it to. But I can say that, again, it's a very rigorous environment. I think one thing I like about MIT a lot is that there's a real commitment to excellence. The people that we work with, and one thing that I advocate in my research and in my work in general is, it's better to not do something than to do it halfway, right? I think, at a place like MIT, one thing we learn a lot about is doing things excellently, right? We have a certain kind of quality that you want to deliver. And that's something that I really appreciate is really having a very high expectation for the quality of the work that we do. Obviously, at a place like MIT, you're surrounded by just these incredibly brilliant people, right, that are doing just work that's at the forefront of so many different fields. So it's very humbling. I'm always in these rooms where I'm just with these people and I'm like, wow, like I'm just so blown away by the work that you do and how you think and how you work. So I think it's a very humbling experience, and it's a great privilege, right? I feel an incredible amount of privilege to be at a place like MIT that has so many amazing, bright people working but also, we have a lot of privilege, right? There's a lot of resources that are available to us that not everybody has access to. So another thing I think that's important for me personally is just the idea that, MIT should be working in a way in service to communities around the world that are interested in science and technology, right? That we should be collaborating and that we should be working in a really open and collaborative way with global communities. And that's something I care a lot about.
Nice. Thank you so much. Okay, so next question. Tell us about the Bio Summit. What it's about. I think you've already talked about that earlier. But maybe you could focus more on what was the mindset behind what has been done and what you intend to do, and are there any thoughts around Africa?
Yeah.
Thoughts around Africa.
Yep. Yeah. So the Global Community Bio Summit, we organized the very first event in October of 2017 and had our second Bio Summit this past October in 2018. Actually, I'm sorry, the first one was in September 2017. But basically, when I first came to the Media Lab and started this group, what had been kind of a need, it felt like for a very long time, was some type of way to convene and bring together folks all around the world that were working in the life sciences, but in a very community-driven and grassroots way, right? One form of that has been described as DIY or do-it-yourself biology, right? And there are in the US and Europe and all around the world now what are called community biology labs. So spaces where communities can come in, learn about the life sciences and really do some innovation as well. And again, these are spaces that are public facing, that are, I think, different than academia, right? For academia, for a college or a university, you have to enroll in a program. In a corporation, you have to get a job there, right? The community lab serves as this very valuable, I think, civic function, right? It's a place where people can go and actually learn about science and the cutting edge of these different technical areas. And so, but what had not happened was a venue and a way to actually convene people from around the world, right? And so the Bio Summit was something that I led the organizing of to really fulfill that need, right? And the Media Lab, I thought, played a very valuable role because the Media Lab has that convening power, right? I had access through being at the lab to this very beautiful space where a very big meeting like this can happen. Access also to sponsors and funding. Each of these events cost more than $100,000 to organize, right? So, there's a lot of fundraising that has to go into this. And, almost, the vast majority of that budget is just to fly everybody from around the world, right? And so, we have to fly and house and feed all of these people. And so, this is very different than a corporate event, right? Our colleagues, as from different places of the world, they don't have hundreds of US dollars to spend on a registration fee, right? So I think for me, it was very important to leverage the institutional power of MIT to try to execute an event like this. And so, and again, formats like this conversation happening virtually are really valuable, but there's nothing like being able to meet in person, face to face with somebody, and really have that face to face interaction. And so the first two Bio Summits, I think, have been at one level, sort of like a family reunion with people around the world that you didn't know that you had this shared kinship with, shared interest and a shared vision with. But then a really opportunity for strategy and planning, right? And again, a word that I like to use a lot actually is a global movement, right? Thinking about this thing, not just about as individual labs trying to do something, but actually trying to coordinate and build a larger global movement where, people feel like they can participate and join and get activated. And there's a lot of structure and planning and organizing that needs to happen around that. And so I think the first Bio Summit, I think, really was more like a big family reunion. The most recent Bio Summit, I think, was really moving much more into structure and strategy, right? And if you think about it, and this goes back, I think, to some of the concepts around collective intelligence. If you think about it, what brings the global community together, right? it's not a hierarchy, right? There's no CEO, right? That's not like there's one person that says, hey, Kumasi Hive, like go do this, and or BioCurious, go do that, right? People just do what they want to do, right? There isn't it's not organized even like a democracy or like a market, right? So what brings a community together, right? And I think there are a few things, right? One for sure is a shared purpose, right? That we all have some type of a shared vision that we want to achieve together. And so one thing that we did at this past Bio Summit was we worked very closely with a community organizer, a guy named Marshall Gans. And Marshall is a legendary community organizer. He's worked with guys like in the US, like Martin Luther King, Cesar Chavez. He helped to organize the presidential campaign for Barack Obama in 2008 and in 2012. So he's a very, very experienced and really legendary community organizer. And so we brought Marshall to the Bio Summit to help us think about how do we structure this movement. And so we ran these exercises, for example, and this, probably almost 300 people participate in an exercise to actually develop a shared purpose statement, right? For us to say, hey, what is our purpose? And actually, if you want, I can read that to you. I have to find it. But it was a really beautiful statement. And actually, let me try to find that actually, because I think it is a valuable thing to share. While I'm looking for it, one of the things I think, again, about the Bio Summit, it's not just about shared purpose, but also, for example, shared ethics, right? What are the things that we think collectively are okay and not okay to do in something like the life sciences, right? And also shared needs, right? What do we need as a global community, right? What's the infrastructure that's necessary? How do we get funding, right? What are the resources that we need, right? So these are all big strategic questions that I think could, spent a lot of time working on at the Bio Summit. And I just found the shared statement of purpose. Let me read this to you. So, and this was again co-developed by several hundred folks. And it says, our shared purpose is to fundamentally transform the life sciences and democratize biotechnology to inspire creativity and improve lives by organizing life science change makers and bioenthusiasts to build an inclusive global network, cultivate an accessible commons of knowledge and resources, launch community labs and projects, and enable local educators. Right? Pretty beautiful, right? Yeah. So, but we had to go through a process to generate that statement, right? And once you have a statement like that, you can look at that and say, you know what, this is something I believe in. This is something I want to be a part of, right? So I think, the first two Bio Summits, I think were, valuable in that way. And Bio Summit 3.0, which is happening in October 11th to 13th, this fall, again at MIT, is expanding and building upon that, right? We actually just launched a Community Bio Fellows program. We're actually in the process of reviewing these applications right now, and we're going to have a cohort of fellows, again, globally diverse from all around the world, that are going to work closely with us and also with Marshall Gans and his organizers to go through a leadership development program, right? To learn about some of these strategies and tactics so that we can bring these tools back to the communities wherever you are in the world, but then also be critically a part of this global network, right? So that's a big part of what we're trying to do, is just organize this community, provide resources, and really take this global movement to the next level. And again, it's been really exciting. I've been noticing there's a lot of applications from folks in Africa. So I'm sure we'll have a great cohort that'll be a part of our fellowship program from Africa as well.
Yeah, nice. So for the fellowship, is it still open?
The due date was this past Wednesday evening, unfortunately.
Okay.
Yeah.
But when is the summit itself open?
The summit is October 11th to 13th this fall. And the applications for the summit have not been put out yet. So there's still time for that. The fellowship program, though, is starting next month. So that's why we just had that happen. We're still reviewing applications right now. If there is a person that sneaks in an application late, we may review it. So I'll just say that. But in general,
can you just say the link?
Sure. It's biosummit.org/fellows. FELLOWS. biosummit.org/fellows. That's the link.
Nice. Thank you for that. Just a quick question.
Yes.
before I go into, so there are a lot of other personal questions here which people ask. Okay, let me just go into one personal question.
Sure.
What's your best food, and do you know how to cook it?
You know, when I was in Ghana, I had some of the best food there. Some of the chicken and rice that I had out there, man, was so good. It was so good. I don't know how to cook it myself, but I miss it. I also miss the banana chips. That was another one of my favorite things that I ate. So good.
Nice.
But, you know, I'm Chinese, so obviously I love Chinese food. I love my mom's cooking. I'm a very bad cook, unfortunately. So I wish I was a better cook. But you know, one thing I feel very fortunate about, living in a place like Boston too. There's so many different types of cuisines. So I love Thai food, Indian food. I love American food too. You know, I love kind of burgers and that type of thing. But yeah, I enjoy all kinds of different cuisines from all around the world.
Nice. Thank you. So this next question is from our research hub here. So usually they do a lot of designs, VLSI designs,
Yep.
create a lot of DSP chips.
Yep.
But then the next phase is to manufacture, probably through all this foundry like MOSes or TMC,
Yep.
all the foundries we have. So the next question is, how do we create such partnership? Is it possible with MIT? Is it possible with how do we create such partnerships such that we can have like fabless design labs in Africa, and then send designs to foundries outside Africa to maybe manufacture for testing and then ship it back, just like the way we have Snapdragon and all these companies.
That's a really great question. It's a challenging question. I think a lot of this is really through different networks, right? So how do you kind of find strategic partners to kind of build with and work with? And when you say we, which the we are you talking about? Are you talking like from the African perspective? Are you talking about would be universities in Africa or companies in Africa being able to collaborate? What kind of institutions?
With our research hub, so Vilsquare has a research hub here, and basically we do a lot of VLSI designs, but it's still in just hobbyist level because we've not been able to figure out the other part, which is the real manufacturing part.
Yeah.
Where we test stocks and wafers and all this. So we currently do all the designing things like Kindes and electric. So how do we now move from that to the real thing, considering the costs, because it's very expensive.
Yeah, that's a really great question. I mean, one thing I might be able to help you with is, I might be able to provide some introductions to some folks at MIT that are doing, work in semiconductors. MIT actually just built a huge, amazing building called .nano. If you look at it online, you can find it. But it's basically a big nanotechnology facility, and they're doing a huge amount of semiconductor work. So all kinds of wafer handling, nanometer level precision work, basically. So as a part of my master's thesis before I got into biology, I was working on fabrication, actually nanofabrication. So electron, ion beam lithography. Actually, that was part of my background before I got into bio. And so, and all of those techniques rely upon semiconductor and lithographic techniques. And you're right, it's really, especially if you're talking about very precise feature sizes, then you need really significant infrastructure. You need all of the filtration systems to reduce the amount of particles, right? So these are clean rooms, right? You need clean rooms they're different class clean rooms, and the more filtration that you need, basically the smaller the feature sizes, the more filtration and the more infrastructure, right? In the US, these are often like extremely expensive facilities. Like to make the types of integrated circuits that are part of your computer. I mean, these are chip fabs that could be like $1 billion chip fab, right? You know, Intel, for example, they're making these processors. There are ways, though, to do wafer level processing that is not as expensive. And so one strategic question is, you know, is the goal to try and build a facility like that in Africa, right? And again, I think one thing that I've seen in the life sciences as well, and interacting with colleagues in Africa, so much of it is about the supply chain, right, and the infrastructure, right? What kind of materials and reagents are easily accessible locally, and what would you have to work with a partner remotely, right? So one potential could be if you found a partner that could actually, if you work on the design library, right? Because again, you can do that through information technology and the internet. Could you then partner with an entity that actually could do the fabrication and testing, right? So you could get some feedback and then improve your skills on the design side if you had a partner on the fabrication side, right? So that might be a type of partnership that could work. Because, you know, setting up and building out a larger fab, that might be really economically challenging and require like a lot of other things to happen at the same time, right? Because it's not just about building the infrastructure. It's how do you source all the silicon wafers and the photoresist, and where is all that getting shipped from? You know, is it getting shipped from Europe or wherever, right? And these supply chains may be very challenging. So again, part of my work right now as well, you know, I'm also working with different communities in Latin America that are also facing, you know, similar challenges in terms of access to infrastructure, and, you know, adopting the Western approach, you know, that might not be the right way to do it. You know, there might not be enough capital to actually, you know, build out all the infrastructure that you need. So one of the questions is, you know, where are your strategic advantages? You know, what are things that you can work on now and build out capacity, you know, and partner with people in areas where where the strength and the ability level may not be as high, right? So, and that's where, you know, developing proficiency in informatics, for example, and this is again going back to the life sciences a little, but it is really valuable, right? You know, you've got access to the internet, you've got access to different types of information technology, so that could be an area, a lower and easier access area, a lower barrier of access, basically, to get involved in innovation.
Okay, that's great. Thank you so much. We'll talk about that probably in email. So we'll also make it open to people who watch the video. So next question. So have you worked on any research you consider groundbreaking?
That I consider groundbreaking? I don't know if I would consider it. I mean, others may, I don't know. I feel like, you know, in my doctoral work, one of the first things that we did that I was very proud of, you know, we demonstrated the first ever microfluidic DNA assembly. DNA synthesis, the ability to create completely de novo or completely new molecules of DNA that have never before existed in nature. It's one of the most important technologies of the 21st century. You're literally talking about being able to create, design in a computer, basically new code to reprogram a living organism. And the DNA synthesizer is a machine that can produce that molecule, right? In the history of recombinant DNA technology, you're always working with DNA that existed, that you found in nature. But you're literally talking about being able to print new molecules of DNA that have never before existed. And so as part of my doctoral work, we demonstrated the first time that you can miniaturize this process into a tiny chip, into what's called a microfluidic device, which actually you need semiconductor technology to make, right? So you use kind of wafers and photoresist and so on to create these devices with very, very tiny features with, automated pumping and, it's literally a lab on a chip. That's another way to describe it, is lab on a chip technology. And so we were able to basically miniaturize the gene synthesis process. So, and now, you know, so many of the commercial DNA synthesis platforms use some form of microfluidics. So I think that work at that time was really, pretty powerful for the field. But, you know, again, right now, I think the work that I'm most excited about is actually things like this, you know, working with global communities and thinking about, in a way, the future of collective intelligence as it maps to the life sciences. So I think hopefully this is work that we can do together and can be done in a groundbreaking way together.
No problem. Great. Um, so quickly, next question. What do you think about Africa?
Well, it's funny. When I was in Kumasi last year, um, Thomas Mboa from Cameroon, dear friend and colleague, Thomas said, you are not born in Africa. Africa is born in you, right? Not sure if you've heard that, but he said that line, and I really felt that. I think being in Ghana last year. That was a life-changing trip. I really, it was one of the most amazing experiences of my life to be both in Kumasi and also in Accra. I feel like I was so fortunate to meet, so many folks from all across the continent, and I learned so much. It was such a wonderful experience, I think, culturally, and then just to see so many diverse perspectives. Again, the music. I mean, Afrobeat's such a big part of my life now, and I wouldn't have it any other way. So, and I really, it's funny, my father, he, there's a fun fact about me, actually. I'm a direct descendant of Confucius, okay? The philosopher. And my father, he was very, very, interested in Confucian philosophy and Chinese history. And he always said, you always have to think deeply into the future, right? When you understand the present, you have to look at the past, but you also have to think about the future. And when we think about the future, being able to, and he also loved Go, the game, the strategy game. It's kind of like chess, but it's an ancient Chinese game called Go. Go requires you to think many, many moves in advance. So when you have an opponent, you think many, many moves in advance. And so my father loved thinking very far into the future. I mean, he always said, David, you look at the world, right? And and this was my father passed away in 2008. So even as in the 1990s and the early 2000s, he would say, it's very obvious that China would become a major force, right? And this, was before, now obviously China is just one of the most important countries in the world and most important regions in the world. But it was pretty clear even 20 years ago that China was going to be this major force. And my father, he would say to me, China is going to come, but really, look in the next area is going to be Africa. It's going to be Africa. And he was, my father actually did a lot of work with the United Nations and actually did a variety of work in Africa. And he had the good fortune of traveling there and doing work there as well. And I really felt that too. I feel like there's a type of an energy right now, I think, in Africa, with different colleagues that I've met and had the really privilege of working with. And it's really exciting. I think there's a tremendous energy and enthusiasm, and I really feel like the continent broadly is on the rise. And of course, each country has its own different issues that it's dealing with. But I really feel like in the coming decades, we're really going to see a lot of amazing things coming from Africa, and I hope to be a part of that too.
Great. So we just have two more questions.
Okay, sure.
So what advice do you have for people who admire you and want to probably go to grad school in MIT or from Africa? What advice would you give to such person?
Great question. That's a great question. That's a really, really great question. Because again, I think it's one thing to say, work hard, do innovative research, but that's kind of not, it's a little too boring, or not boring, but it's, it's not enough. I mean, I think one of the big questions, getting into a place like MIT is very hard, right? Again, it's a very challenging, it's a very competitive environment to come and go to grad school at a place like MIT. So a lot of it, I think, has to do with persistence, right? Being able to, continue to work hard and do great work, but also to have a really strong sense of dedication and work ethic. Again, I think it's, I came from a very privileged background. Again, my father was a professor at MIT. I have all kinds of advantages that I personally had all kinds of advantages that, I recognize that, people around the world, of course, do not have. So I think it's so it's not just about working hard. I think it's also, trying to be very strategic and trying to find the right types of partnerships and really developing the right types of relationships so that you can start to build those bridges and connections with places like MIT. And again, for me personally, that's something that hopefully I can help with, right? I know, of course, that, there are a lot of people that would be excited to go. And at the end of the day, I think MIT does do a pretty good job at trying to identify students that will really thrive and have the kind of the character and the work ethic and the kind of abilities to thrive at a place like MIT. So I would recommend, again, trying to find great projects to work on. Finding good collaborators is very important. And a lot of it is just sustained effort over a very long period of time, right? You have to build up that kind of track record that you can do good work, right? And hopefully, right, through some of the work we do together, through community bio and through a lot of the grassroots work, we can help to develop the types of institutions so that there are opportunities for folks in Africa to show that they have to demonstrate that work, right? There's zero doubt in my mind that the colleagues and friends in Africa doing this work every single one has the potential to do great work at a place like MIT. And so the question is to how to harness that potential and turn that into the types of projects that and the types of experiences that would allow you to thrive at a place like MIT. So those are just some thoughts. And I guess, the other thing I would mention too is, in everybody's journey, we all have this kind of ongoing process of challenging what we think we're capable of, right? I think it's, when you are somebody like me and you grew up in a place of great privilege and have somebody, both my parents were professors, it was very easy to imagine, being like a life as in academia, right? Because you've got role models, right? So I think there's this always ongoing journey to challenge what you think you're personally capable of, right? And it's a process, I think, that involves, I think, having different types of challenges and overcoming those challenges. I remember the very first time I taught a graduate class, at MIT. I was only a few years older than the graduate students, and I was just like, man, how am I going to teach these graduate students? They're smarter than I am, and I'm supposed to be the teacher here. And I prepared super, super hard. I worked really, really hard to just kind of get the class as best prepared as I could. And after I did it the first time, I was like, you know what? I can do this. Actually, it's possible for me to teach a class and do a really good job. And then the second time I taught the class, it was easier. And the third time I taught the class, it was even easier. And now, teaching for me, I feel very, very comfortable teaching, right? I feel very, very comfortable working with students and trying to get the classroom excited and get, the students to expand their imaginations. So I think, in whatever you do, it's super important to just continually challenge yourself. And as you challenge yourself and get out of your own comfort zone and overcome those challenges, you become more extraordinary. And, just keep iterating through that process over and over and over again, I think is how we just kind of develop ourselves. And hopefully, for some friends and colleagues in Africa, MIT will be a part of that process, a part of that challenge. Because I can tell you one thing that MIT is extremely good at, and probably one of the best places in the world at, is providing challenges, right? So if you want to if you want to find the best, most challenging problems in the world, a lot of that is being worked on at a place like MIT.
Great. Okay, so final question. Someone asked, what do you think about open science?
Mm-hmm.
And okay, let me just keep it because it's very long. So it says, what do you think about open science in Africa?
Yeah. So again, I think open science is a huge area that I am personally just a really major advocate for. All of my work, I think, connects in some ways to open science, right? And open science, I think you can define that as science that is shareable, that's transparent, that is highly accessible, right? And again, I think open science is particularly in a context like Africa, I think. there's a really interesting question about, ultimately who has access and how do you create create pathways for that access, right? Obviously, in different parts of Africa, right, there are different challenges that one might experience in getting access to certain tools or certain reagents or certain materials that you need to do science, right? And so, to the extent possible, being able to enable folks to work locally and work with resources that are present locally to advance science is extremely important. And I think, personally, a big part of what I care about. And so being able to have open science, meaning that you can share openly the protocols and the designs and so on, is critically important for that, right? And so if you might ask, there's open science, what's closed science, right? Closed science is a lot of things that might happen, for example, in a corporation, right? Where, you're not going to be able to see the processes and the protocols, right? And, by definition, right, in a for-profit enterprise, you're trying to maximize profits and you're trying to build out your products and you've got your intellectual property. So you're not going to be as willing to share certain things, right? Even in academia, which I think should have a much more open philosophy, even academia is pretty closed, right? You're competing with other principal investigators to get a research grants and so on. So you're also not going to share a lot of things until you get to the publication. And oftentimes, even in the publication, it's hard to figure out what people are doing, right? So I think, really trying to create tools and technologies and processes that will allow very, very diverse populations and communities to work on it. It's not easy to do. But again, part of what I personally care about it is trying to create those opportunities and trying to create that infrastructure and those technologies to make science as open and as accessible as possible.
Thank you, Dr. David. Thank you so much for accepting the invitation to join our first Hangout series. I just asked if you have any last words before we end this edition of the series.
Yeah, I would just say, thank you so much again, Oba, for organizing this. And again, for anybody listening or that may listen to this in the future, it's a real honor and privilege to be here. I know for myself, I'm really excited to support efforts and work happening in Africa. Again, I go back to the line from that Thomas shared about, Africa. You were not born in Africa. Africa is born in you. I feel like there's definitely Africa born in me through my experiences and through my work with you all. So I hope this is just a part of a longer journey together, and I'm really excited to continue working with you and other colleagues throughout Africa. So thank you so much again for having me.
Yes, so we're so super excited to have you. Vilsquare says thank you so much for coming, and we hope to have more of these collaborations in the future with you.
Sounds wonderful. Great. Thank you so much again.
Yeah, have a great afternoon.
Yeah, have a great evening as well. Have a great dinner. I know it's probably dinner time over there, so you must be very hungry. So please go get some food. Okay, enjoy. Have a great weekend. Okay, take care. Bye-bye.